Hi, this is Jeff from Sabe. This is the fourth and final video in our series about Sabe and DDMRP and buffer management. In this video, we'll take a look at the adaptive buffer simulator and the buffer profile distribution. These are graphs that people like to see because they have nice, interesting colors and simulations. So I'm back to the obfuscated instance. This is real data from a company that's having some problem with replenishment policies on their low value purchase items. And I have an item in mind that we'll be taking a look at. It is 106061. Okay, this is a purchased item. We have top of red, yellow, green, demand spike threshold set, and a horizon set. What I'm going to do is right mouse click on this part, and I'm going to go to the adaptive buffer simulator. Now this is a tool that goes back in history, looks at consumption history, and builds a simulation of how DDMRP would respond given the buffer definitions, the analytic period, and the analytic resolution, which we should probably set to 3 days because 0 doesn't make any sense. I'm considering demand spike at 50% of red zone and 100% lead time horizon, so let's run this. So I think we have data from, say, 2012 from this firm. So we're going all the way back to the first instances or first consumption of this item. And then we're moving forward, building red, yellow, and green zones. And you can see how historically DDMRP would have responded to the consumption profile of this item given these buffers. Moreover, we can take a look at the net flow position and the simulated QOH to see, given that consumption and given the suggested supply, what the inventory position would be over the course of the last 5 years. From here, we can do interesting things like change the order frequency and perhaps the analytic period. Oops. And rerun the simulation to see how that would affect our buffering. But even more interestingly is because we have not only the consumption history but also the actual supply history, we can compare this simulation with what this planner did on this part. So I'll just turn on show historical supply in QOH and rerun the simulation. And now I see 2 more values being displayed. One of the values is QOH, actual historical QOH. So this is where the inventory values were actually during the past 5 years, and the excess value. So you can see with the historical QOH, the actual QOH, you can see that their replenishment policy bought quite a bit more inventory than DDMRP would have suggested that they had. Moreover, you can see with excess value, which actually is on this line, excess value indicates that only in very few cases did their replenishment policy beat the inventory value position of DDMRP. So what that's saying is that this is the difference in what they had on hand versus what DDMRP would have suggested they purchase or have on hand, multiplied by the direct cost for this item. So I can go to simulation details and I can actually see the effect. I have an average excess value of $504 or euros. Although we're not trying to chase inventory reduction, that's not the goal, buffer management, with low value items, you often find that the planner is going to overbuy in order to avoid that stock out. We'll take a look at the bimodal characteristics of this inventory in just a moment, but you can see that this buyer is overbuying this inventory because he or she desperately wants to avoid the stock out, because it's very likely that this $8 or euro part or $9 or euro part is a critical item and a component that is worth quite a bit more. And they don't want to constrain the throughput on that component. So we can go back to simulation details, and I have this little gear right here. If I click that, I can actually export this right to a spreadsheet for additional analysis. So I can open that up, and if I want to front load my existing ERP with this data right here, I can do that. or I can do any further analysis that I want. That's pretty common throughout Sabe, the ability to export to spreadsheets. So this is a great tool to understand how DDMRP works and how it reacts to various parameters such as different analytic periods or different sizing of the zones. And of course you can also insert or you can define zones by the LTU factor, which is classic DDMRP, and we can play around with the demand spike as to what actually qualifies as demand spike. All you have to do is reset the parameters and rerun the simulation, and we'll get the visual representation as well as the tabular representation of the data. So again, this is a tool that is used as a diagnostics tool to figure out what's going on and what we want to do. We have a more actionable tool, however. So this and utilities and buffer position distribution. I'm going to look at planning category BM. Now, if you've ever watched one of Carol or Chad's webinars, and you should, you'll hear them talk about bimodal inventory, how if you're not using DDMRP or any form of buffer management, your inventory is bimodal whether you know it or not. And in this case, you can see we have bimodal inventory. So this is actual inventory in a bimodal state. These are low value items, so often with low value items, they're bimodal. They're buying too much to avoid this position right here. So we have a stock out with allocation on 11 items. We have a zero quantity on 123 items, and they're really trying to avoid that. Again, these are nuts and bolts and screws and small items, so it doesn't, in their mind, the planner's mind, take a tremendous amount of cash to do this, buy too much to avoid this, stock out. If these were more valuable items, motors or control panels, we'd probably see more stock out because the site just can't afford to purchase too much of those high value items. But nonetheless, we see a bimodal nature. Now in Sabe, we use dark red to indicate stock out with allocation. This is the percent or the relative penetration to the red, yellow, green zones for the items in question, item sites in question. Blue is, of course, excess, and we use purple, blue with red on top of it, for actionable events. Now, the actionable event is that we have excess and we're asking for more. So if I click on that, I can see these items right here are not only over top of green, but they're over top of green, and we have these are purchase items. So I can right mouse click, and I can see that we have a purchase plan out there for it. There's a purchase order for this item that Sabe is saying we should cancel because we're over top of green and therefore should not be buying anymore. Excess at direct cost shows us our value over top of green. So what this is suggesting that if all these items are usable, none are obsolete, and likely some are obsolete because when you buy too much, you end up with too much. But if none of these items are obsolete, we have the opportunity to burn down this inventory to top of green. And when we do that, we will recover $811,000 or euros from inventory to cash. Moreover, you're really not going to burn down a top of green. What you're going to do is you're going to cycle somewhere between the middle of red and somewhere around the top of yellow, middle of green. That's classic DDMRP cycling, which means there's even a greater return to cash possibility. Now, if you go back to the second video, and take a look at my talk about the update planning parameters, you'll see that for this customer, not only do they have an issue where they have too much of some things, they have an issue where they have too little of other things. So not all of that is going to return to cash because we have to correct this situation over here. But this is a KPI. It's not a numerical KPI, but it is data visualization. We can actually play this over a period, and we can watch this bimodal inventory merge into a unimodal inventory or a bell graph distribution, which is where we really want to be. So not only do we have this at buffer profile distribution with detail, but we have it on our dashboards where we want our manager to go every single day to figure out where they need to be working on their enterprise in order to obtain that illustrious goal of operational excellence. So in summary, first video we talked about the master information. Second video we talked about establishing buffer profiles, planning policies, planning categories, and setting the red, yellow, and green zones for all of these items. In third video we looked at a single item, but we saw how Sabe will create a replenishment plan for that item and how the planner can release that replenishment plan. And finally, here in the fourth video, we take a look at the buffer profile distribution and the adaptive buffer simulator. Now we have one other screen that I want to show you. This is live data, so keep in mind that it's probably not going to be pretty. 6061. So we saw the adaptive buffer simulator, which is what could have happened. If we go to the buffer visualizer, we can see what really did happen. So what Sabe does, whether we load data from a legacy system or we're live, what Sabe does is every day it takes a snapshot of, for every single item site in the database, the current position, inventory position, the then current top of red, top of yellow, top of green, and the then current net flow position. So what we can do with that data is plot historically how this planner has been operating to the suggestions. Now, this is live data, so you can see before we load it into the system and we set some DDMRP parameters, which happened right here, we really didn't have much in the way of buffer management. In fact, it looks like they just buy a whole bunch every time they get scared. Moreover, it looks like they have top of red set above top of yellow somehow. Again, this is legacy data, so we can't control the data validity from an older system. But over the course of time, we're going back a year, typically a year on the buffer visualizer, we can compare what DDMRP or any of the other replenishment policies we support suggested the planner do to what they actually did. So this is the historical QOH, and these are the historical resupplies and the historical consumptions right there. So this is a great tool for either the planner to use to figure out how they can better react to what buffer management is suggesting they do, to figure out why buffer management might not be working for a particular item, or it can be used as a coaching tool to help a planner get their arms and head around what buffer management is and how it reacts to usage and how they react to the input signals. So the adaptive buffer simulator, which will go through and show what Sabe or what DDMRP would have done. The buffer visualizer, which will show what really happened, and then the buffer profile distribution, which shows over all items how well we're managing the inventory. And once again, if you don't believe you have bimodal inventory, why don't you send us a spreadsheet? We'll show you that you do, because if you're not using buffer management of some sort, unless you're throwing a lot of manpower at the problem, you can almost guarantee that you do have bimodal inventory. So that's it for DDMRP. In future videos, we'll be taking a look at the constraint status. We tickled that in our last video, but that is used in conjunction with DDMRP to prioritize order release. And throughput pricing, which is also used very well with DDMRP to understand when and when we shouldn't take an order. Until then, send us a spreadsheet and we'll make this work for you. Thanks. Bye.